Hi everyone, I'm Hao Tianliu, a PhD candidate from Tongji University. I feel honored today to share our recent work on event-based optical flow, TMA, temporal motion aggregation for event-based optical flow. I arranged my representation by three parts: the background, the proposed method, and experiments. As we know, recent learning methods for event-based optical flow usually remove the paradigm of conventional images by representing the event stream as two frames. These methods actually achieve good results, like erupt. However, the inherent temporal continuity of event data is ignored. At the same time, we find that event cameras are capable of capturing more scene dynamics owing its spatial imaging principles. The observation gives us a thought: is that possible to unleash the temporal continuity of event cameras within a learning-based framework? To this end, we propose a method called TMA in our paper. It consists of three key components: an event splitting strategy to incorporate intermediate motion information from events, a linear lookup strategy to align temporal fine-grained motion features, and a motion pattern aggregation module to emphasize consistent motion feature patterns after linear lookup operation. This page provides an overview of our TMA framework. At first, instead of viewing the continuous event stream as a static frame, we view it as a high frame rate video clip. Based on this, we split the event stream into multiple segments and get features through a share-weight feature encoder. Thus, we can compute the temporally dense correlation volumes by correlating all these features. The benefit is that temporally dense correlation volumes can compare feature similarities across multiple time spans, enabling refined records of relative motions. Next step is lookup. Recall that each correlation volume is achieved by correlating first feature and one other, which means the recorded relative motions are misaligned in time. To align these correlation maps, we then propose a linear lookup strategy. Based on that, correlation volumes are evenly constructed in time, and the magnitudes of optical flow change linearly over a short period. We narrow down lookup's coordinates in a linear fashion to sample the correlation volumes. As a result, similar motions are presented as same pixels across correlation maps. Finally, we notice that the majority of motion features, intermediate ones, will dominate the flow regression if we just concatenate motion features. However, due to the linear optical flow assumption in the manual lookup operation, intermediate motion features are not perfectly correct. Therefore, we propose a motion pattern aggregation module to put more emphasis on the last motion feature, which is without manual lookup, and retain the patterns in intermediate motion features that are consistent with the last motion feature. We evaluate our TMA methods both on DSEC flow and MVSEC datasets and compare our method with current SOTAs. Here are the experiments results on DSEC flow. We can find that our TMA can significantly boost higher accuracy by a large margin. Not only on DSEC flow, our method achieves excellent results on MVSEC as well. We have conducted extensive ablation study to verify the effectiveness of each subpart of TMA. In summary, we propose our TMA approach for learning-based event optical flow, which effectively utilizes the temporal continuity of event data. Thanks for your watching. Our code is already available at GitHub. If you have any other question, please feel free to contact me.